Hello, ndikulandire muzilatra sabata ino pamene tikupitiriza the graphs of quadratic functions. Lero tili mu lesson 3 ndipo here we are mostly doing interpreting graphs of quadratic functions. So we want to see the effect of adding or subtracting a constant from the quadratic squaring function, i.e. this function. So the issue is if we want to add a constant, okay, I will take example for my quadratic functions. Y is equal to x squared plus, in this case is plus 0. The second one is y is equal to x squared minus 1. And the other one is y is equal to x squared plus 1. So we need to draw these graphs, this quadratic function on the same graph, and the values, table values, will have to range from -4 to +4. So let's now draw these graphs these functions on the same graph and see what the supanga behave more than. The whole idea is to see the characteristics that these graphs, when you add a constant, when you subtract a constant, what the imaoneka bwanji, imakhala bwanji, zimasiyana bwanji. So says it is cholinga chonena kuti timvetsetse kuti kodi quadratic graph imakhala bwanji, chifukwa at a later stage on the first lesson tinaonetsa kuti idzakwana nthawi imene tidzafunike kupanga ma quadratic functions from a graph. So for us to achieve that, we need to first of all understand the quadratic graph, kuti imapanga bwanji behave. So let's draw these ones. So the first thing first, timachambula table of values. So we remember the first quadratic function was y is equal to x squared. Is equal to x squared. Okay, let's have table of value of that one. So remember it was between -4 and 4. So we're going to say that's x. This is y. Okay, so -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, so let's find the value of y against those x values. So in this case, y is equal to x squared. So -4 squared, that's 16. That's 9. That's 4. That's 1. That's 0. That's 1. That's 4. And this is 3. That's 9. And that's 16. Okay, so we do the same with other function. The other function is y is equal to x squared. In this case, -1 squared minus 1. Table of value of this one. Okay. Let's draw table of value of that one. Yeah. So the table of value of that one, the values are the same. We have -4. -3, -2, -1, 0, 1, 2, 3, 4. So if we say x squared, that is -4 squared, that's 16. If we subtract 1, that's 15. Okay, so that's that. The last one is y is equal to x squared plus 1. Table values, we have x and y, but it should move from -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, so sorry. So -4 to squared, that's 16. 16 plus 1, that's 17. That -3 squared, that's 9. 9 plus 1, that's 10. 4 plus 1, 5. 1 plus 1, that's 2. 0, that's 1. There, 2. 4, that's 5. 9 plus 1, that's 10. 16, that's 17. Okay, so reaching this far, we need to plot this, and we have to plot them on the same graph paper. So let's see. That's helpful. So x-axis is our, this is our x-axis, and this is our y-axis. Let's start by putting up our values. Okay. Okay, so that, so we have 0 there, -1, -2, -3, -4, and then 1, 2, 3, 4. Okay, and on the y-axis, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so this is 1, 2, 3, 4, 5, 6, 7. Okay, so that's it. So let's plot the first one. When x is equal to -4, y is equal to plus 16. So -4 here, plus 16 somewhere there. Okay, when y is equal to -3, x is equal to 9, that's +9. That's where +9 is. When y is equal to -2, when x is equal to -2, y is equal to 4. So it's there. So 4 is there. Now when y is equal to -1, when x is equal to -1, y is equal to 0. And so there 1, y is equal to -1. It's 1. Should be here. So when y is equal to 0, when x is equal to 0, y is also 0. When x is equal to 1, y is 1. When it's 2, 4. When it's 3, 9. When it's 4, 16. Okay, so we can plot graph. It's just a sketch. My sketching is not that good, but at least we're just trying to show each other. It is going to be like that. So that's the first plot. This one we are calling it y is equal to x squared. Now let's look at this one where we are saying y is equal to x minus 1. So for x minus 1 minus 4, when x is equal to minus 4, y is equal to 15. So y is equal to 15. So y is there. It's there. And when x is equal to minus 3, y is equal to 8. It's here. When it's minus 2, y is equal to 3. Down there. Okay. When is minus 1, y is equal to 0. So 0 is here. Okay. When x is equal to 0, y is minus 1. So minus 1 is here. So this one is there. When it's 1, y is equal to 0. Y is equal to 0 is there. When it's 2, y is equal to 3. So it is here. When it's 3, y is equal to 8. So here's where 8 is. Okay. When it's 4, y is equal to 15. So this is where our 15 is. Okay. Alright, so let's also plot our graph. Yeah, so that's like that. Okay, so this one you can see it. We are saying is y is equal to x squared minus 1. Okay, so that's that. And let's plot the last one. So the last one we are saying when x is equal to minus 4, y is equal to 17. So minus 4, y is 17. When x is equal to minus 3, y is equal to 10. So let's have y 10 here. So when it's minus 3, it's 10. When it's minus 2, y is equal to 5. F is there. When it's minus 1, y is equal to 2, and the 2 is here. When x is 0, y is equal to 1, and 1 is here. When x is 1, y is equal to, when x is 1, y is equal to 2, and 2 is there. And when x is equal to 2, y is equal to 5. This is 2, let's see why 5 is here. When x is equal to 4, y is equal to I mean, when x is equal to 3, y is equal to 10. So it's equal to 10. 10 is somewhere there. When y, I mean, when x is equal to 4, y is equal to 17. So let's plot. Okay, just like that, it will be the log. So it will be the log. All right. So reaching this far, we have all the three graphs. Graph will cut the okay, let's show it. That one is equal to y is equal to x plus 1. Okay, so a graph atosa tatani tawapanga, and reaching this far, we need to conclude. We need to conclude on this one. Okay, so let's see. Okay, so if we see, we have three graphs. Y is equal to x squared. Actually, it's y is equal to x plus 1. Yachitatu is equal to y x squared minus 1. Okay, now from we look at the plot from the same graph. We see the shapes are almost the same. Sorry, my drawing is not good, but the shapes shows the same properties. So the shape is the same, which means subtracting or adding has not changed the shape of the graph. And we know that there is this line where x is equal to 0, the y-axis line. Okay, all are turning around this line. Okay, so we can say that the line x is equal to 0 is the line of symmetry. The line of symmetry of these three graphs is x is equal to 0. We all agree on that one. And we also see that the three graphs, they already differ on the points pamene zikupanga cut this y-axis, or this x is equal to 0 line. Okay, tuona kuti x is y is equal to x squared ikudutsa pa 0, pomwe y is equal to x plus 1 ikudutsa pa plus 1, pomwe y is equal to x minus 1 ikudutsa pa minus 1. So chimene chasintha uku tikupanga kuti plus 0, it's cutting y-axis pa 0. But with x plus 1, it's cutting y-axis pa 1. But with x minus 1, x squared minus 1, ikupanga cut y-axis pa minus 1. So the conclusion that we can make from here, the addition of a constant to our sorry, here this one has to be squared. Addition of this constant to our graph, depending on the sign of the constant, it will show where the line is cutting the x-axis. If we have a standard like that one, we know it's plus 0 there. It means it will cut the y-axis at 0. When it's this one, it's cutting the y-axis at minus 1. When it's that one, it's cutting the y-axis at plus 1. So for today, let's stop there. See you next video. Thank you.